Hello everyone, hello lovely students, welcome back to this video session. Hope you all are doing great in your life. My name is Ashwant and I'm from India, which happens to be a very awesome, wonderful country. And today I have got a really exciting math lesson for you all. Want to know what's that? Then please don't skip and make sure to stay with me all around till the end. Here we go. So we have got these two questions for today's session and we have to find the range. And I request you all to pause the video, read these questions carefully and try to solve them on your own. Alright, now let's solve these questions with me. And before we get into solving, I would like to say few properties for finding the range of function. Now, if you observe this structure carefully, it reminds us of a sin x plus b cos x. It's a very popular structure that very often we come across while solving trigonometric functions. So whenever you come across this type of a structure, a sin x plus b cos x, its range can directly be written as closed interval, it's closed from both sides, negative and square root of a square plus b square till positive square root of a square plus b square. So you have to memorize this. So whenever you come across a sin x plus b cos x, its range will be closed from both sides, negative a square plus b square square root and positive a square plus b square square root. So we'll follow this for solving these two questions. So let's get back to our first question of today's session. So we have 3 sin x minus 4 cos x plus 7 and we have to find the range. Alright, so we solve our first question. Solution of first one. So we have 3 sin x minus 4 cos x. 3 sin x minus 4 cos x plus 7. So for 3 sin x minus 4 cos x, I can write it like 3 sin x and okay, so that it looks very similar to a sin x plus b cos x. So a is 3 and b is negative 4. So the range will be what? Negative square root of a square plus b square and positive square root of a square plus b square. We put the values of a and b. So we have 3 square and we have negative 4 square. Again we have 3 square and negative 4 square. Now if we simplify this, 3 square 9, 4 is minus 4 square 16. 9 and 16 is 25, its square root would be 5. So we have negative 5 to positive 5. So the range of 3 sin x minus 4 cos x comes out to be negative 5 to positive 5. And we have to add a constant 7. And in my previous videos, I have taught you that if you find a new functional expression by adding some constant value to the original functional expression, then to get the new range, you have to simply add that constant value to the left hand and to the right hand boundary point. So following this, I can write 3 sin x minus 4 cos x plus 7. So when we add 7 to the original functional expression, for getting the new functional expression, we add 7 to the left and to the right hand boundary point. And this will eventually give us the range of the required function. So the range of 3 sin x minus 4 cos x plus 7 that we were supposed to find out comes out to be close to close 12. Now let's get back to the second question that we have. Okay, so the second question we have is 6 sin x. It's actually the reciprocal of 6 sin x plus 8 cos x. So again we see the structure. So we'll start with 6 sin x plus 8 cos x. So 6 sin x plus 8 cos x. So it looks very similar to a sin x and b cos x, whose range is given as negative times square root of a square plus b square till positive square root of a square plus b square. We put the values of a and b. A is 6 and b is 8, so we directly calculate it. So 6 square plus 8 square 6 square is 36, 8 square is 64. So we have 100 whose square root is 10. So we can directly write here, so negative 10 to positive 10. It's the range of 6 sin x plus 8 cos x. So 6 sin x plus 8 cos x, we have negative 10 to positive 10. Now we will do the reciprocal of 6 sin x plus 8 cos x. Then only we can get 1 upon 6 sin x plus 8 cos x, and after that we'll add 7. So for doing reciprocal, I have taught in my previous video. I request you all once again to watch my previous video so that you can understand in a much better way what I am actually talking about. So to find the range of a function by doing the reciprocal, we have to do the reciprocal of the left hand and the right hand boundary point, but it's not simple here because while doing reciprocal we'll come across 0, and 0, reciprocal of 0 is not defined. So we need to break this interval at 0. We need to break this interval at 0. So 6 sin x plus 8 cos x, we'll write negative 10 to 0 negative union 0 positive till 10. Why we break at 0, this I have explained in detail in my previous video. Okay, so you can watch it and understand. Okay, now when we do the reciprocal, so we have 6 sin x plus 8 cos x, 1 upon 6 sin x plus 8 cos x, and while doing the reciprocal we'll follow the case 1. Case 1, in my previous video I have taught two cases, case 1 and case 2. So in case 1 we have got both the boundary points negative or both the boundary points positive, and in case 2 we have got one boundary point negative and the other boundary point positive. So you see in both the intervals we have this boundary point negative and this one negative, and in the other interval both the boundary points are positive. So we do the reciprocal and reverse the order. So we do the reciprocal and reverse the order. So 1 upon 0 negative, the right hand boundary point will become the left hand boundary point after reciprocal. Same for negative 10, we have negative 1 by 10 and then union. So again we do the reciprocal. So we do the reciprocal, we have 1 by 10 and we have 1 upon 0 positive. Okay, so this will be your negative infinity, and this is your negative 1 by 10 union. This is your 1 by 10 and this is your positive infinity, right? Okay, so 1 upon 6 sin x plus 8 cos x we have got. Now we add 7. We add 7, right? Yes, we have 7 in our original question. You can see here. Yes, we have 7. So we add 7. So we add 7. It will be 1 upon 6 sin x plus 8 cos x plus 7. So when we add some constant, they're actually modifying this functional expression. So we add 7, then we will have to add 7 to all the boundary points for both the intervals. So if we add 7 to negative infinity, it won't affect it. Negative infinity is very large. And we add 7 to the right hand boundary point. It's a finite number, so we have to write it. And for the second interval, again we add 7, and for the positive infinity, if you add 7, it won't affect it because it's very large. So we more simplify negative infinity. If you simplify, it will be 69 upon 10, and it will be 71 upon 10 to positive infinity. So it's 71 actually. And this is our fx. So that's all for these questions. So this was all about today's session, and I did my best to make you all feel comfortable and happy. If you like my video, then please share it to your friends and loved ones, and make sure to subscribe my channel and hit the bell icon to get the notification of my next upcoming video. See you all my lovely friends in my next upcoming videos. More exciting, a lot of awesome questions. Till then, bye bye, stay safe and have a nice day.